Hi students, today I will discuss about chemical reactions and equations. It is there in 10th standard CBSC NCERT book. So chemical reactions and equations. What is reaction? Example, reaction means like acid reacts with base to produce salt and water. Like this is a reaction. So in this reaction we have to write acid means representation of formula or representation, symbolic representation of that acid, or symbolic representation of base NaOH gives us to NaCl plus H2O. So now this is equation, chemical equation. So chemical equation means the symbolic representation of elements present in a reaction in the equation, or any reaction is known as chemical equation. So chemical reactions types is there, types of chemical reactions, types of chemical reactions. That first one is decomposition reaction. So this is second one. First one, combination reaction. So types of chemical reaction, one is combination reaction, second one is decomposition reaction, third one is displacement reaction, fourth one is double displacement reaction. So decomposition, displacement, double displacement, and the next one redox reactions. So in these five types of reactions, first one we will discuss combination reaction. Combination reaction, first one, combination reaction means two reactants combined to form a single product is known as combination reaction. Combination reaction means two reactants chemically combined to form a single product is known as combination reaction. Example for that, A plus B gives rise to AB. Here two reactants, we will get only one product. This is example for combination reaction. So in our chemicals, two reactants combine to form a single product. One is H2 plus O2 gives rise to H2O, here 2, here also 2. So this is combination reaction. Next, C plus O2 gives rise to CO2. C plus O2 gives rise to CO2. This is also combination reaction. So one more example, Mg plus O2 gives rise to MgO, like here 2MgO, here 2Mg. This is also combination reaction. So here all combustion reactions are combination reaction. Combustion reactions, all combustion reactions are combination. All combustion reactions are combination reactions. So magnesium ribbon bonding, it is combustion only, but even also combination. So carbon charcoal or coal bonding in the presence of oxygen, we will get CO2. This is also combustion, but it is combination reaction. This is about combination reaction. Combination reactions, in that one synthesis reaction also is there. Synthesis reaction. So what is a synthesis reaction? Constituent elements of the compound. Example, synthesis reaction example I will say. Want to prepare product like C plus O2 gives rise to CO2. What is the constituent element of the carbon dioxide? Carbon and oxygen only. So this is comes under synthesis reaction. So synthesis reaction means constituent elements of the product. Product will be formed by the constituent elements of the the compound. So in this compound, what is the constant elements? One is carbon, other one is oxygen. This is combination reaction. Now one more example. CO plus carbon monoxide, O2 gives rise to CO2 will come, but here 2 are 4 means here 2. So this is the one more example. So here we are preparing what? CO2 gas, but the CO2 gas comes from where? Carbon and oxygen? No, it is not comes, CO2 not comes from carbon and oxygen, carbon monoxide and oxygen. So this is not a synthesis reaction. Now you got, I think, clarity. Synthesis reaction means constituent elements of the product. That product will be formed from the constant elements of its atoms. So its compound atoms what? Carbon or oxygen. Constant elements of the carbon dioxide what? Carbon and oxygen. Like this only carbon dioxide will form, means that is a synthesis reaction. But here carbon dioxide form from where? Carbon monoxide and oxygen. So it is not a synthesis reaction. So that is the difference between synthesis reaction, and this is also known as combination, but not a synthesis reaction. N2 plus O2 gives rise to NO2, 2NO2 here 2. This is also synthesis reaction, because NO2 constant elements what? Oxygen and nitrogen. From there only it came, this one forms. NO plus O2 gives rise to NO2 will come. So N2O plus O2 gives rise to NO2, like here 2, here also 2, 4, okay, plus N plus N2. So like this, here product is NO2. We want to get NO2 from where? N2 and O2 only, not N2 and O2. So this is also not a synthesis reaction. So that is the difference between synthesis reaction and combination, normal combination reactions. Okay, that is about combination reaction. Next second example is decomposition reaction. Decomposition reactions. So these decomposition reaction, in this decomposition reaction, okay, no need this example, that too enough. Okay, decomposition reaction, the reaction carried out in the presence of temperature, heat or electricity based on heat, electricity means current, based on heat and electricity and sunlight. Three types of decomposition reactions is there. One is thermal decomposition reaction. Thermal decomposition reaction. So that is first one. The reaction carried out in the presence of the reaction carried out in the presence of heat is called thermal decomposition reaction. Thermal decomposition reaction. Example, CaCO3 in the presence of temperature CaO plus CO2. This delta symbol means heat absorbed. We will give heat, temperature. So this is decomposition reaction. Actually here the decomposition reaction means one reactant decomposes to form a one reactant decomposes to produce two or more simpler substances. So that is actual decomposition definition. One reactant decomposes to form two or more simpler substances is known as decomposition reaction. In that thermal decomposition reaction, the reaction carried out in the presence of heat energy or heat is called thermal decomposition. Example is this one is best example. Next, sunlight, that we will call photo decomposition reaction. Say in this reaction, the reaction carried out in the presence of sunlight is called photo decomposition, photolytic decomposition also we will call photolytic decomposition reaction. Photolytic decomposition or photo decomposition. So example, photolytic decomposition example, AgBr gives rise to, in the presence of sunlight, Ag plus Br2. So 2AgBr changes into 2Ag plus Br2. Here yellow color AgBr changes into gray color. So when silver bromide kept in one watch glass in the presence of sunlight, we can keep in watch glass in the presence of sunlight, this yellow color of AgBr changes into gray color. So then only we can identify gray color means it is decomposition happen. Br2 is Ag and Br2 are bond will be breaking. So yellow color changes into gray color, then we can identify. This is the photolytic decomposition. Photolytic decomposition. Next one is electrolysis. So electrolysis means this is the reaction carried out, the decomposition reaction carried out in the presence of current or electricity or current is known as electrolysis. Electrolysis or electrolytic decomposition. So this is also one type of third type decomposition reaction. Here we can take one mug. For that we can take these two graphite rods. Here this is a rubber cock arranged in the in this mug. So inverted test tube we can keep like this. Here also one more test tube. Inverted test tubes we can arrange it like this. Both the electrodes are like graphite rods. So this is electrode are graphite rods. So here switch and wire is there, or switch. Inside water, acidified water. Test tubes also having acidified water, otherwise acid plus some drops of acid and water we will call acidified water. This is mug. This is a test tubes, inverted test tubes both. So here this side we can take positive, this side we can take negative. So here inside water and acidified water to conduct electricity. What is the use of acidified? Acid is there means it will conduct electricity, otherwise pure water didn't conduct electricity because there is no free ions. When acid some drops added, it will conduct electricity. When we can apply the current, it will be electrolysis happen. That means water will be decomposes like H2O decomposes like H2 and O2 gas. H2 and O2 gas. So here balance the equation. 2H2O, 2 moles of water molecule decomposes, we will get hydrogen gas, 2 moles oxygen gas. So in this water electrolysis happen. That means decomposition of water molecule, it will be one side oxygen gas, other side hydrogen gas will come. This side, this is a positive terminal, oxygen gas will come in this test tube. So oxygen gas here only is there, thicker. Hydrogen gas like in this thick, so more hydrogen gas is there. Why? 2 moles, no? So that only. So this is now hydrogen gas. How we know which is hydrogen, which is oxygen? Yes, I will say. So we can remove this test tube after electrolysis. Burning matchstick. So this is our burning candle, our burning matchstick. You can imagine this is flame. We can keep in the test tube with the mouth of the test tube with that burning matchstick or candle. This flame will be increased. That is oxygen. Flame increase, that is oxygen. Supporter of flame, no? So flame or fire will be increases, that is oxygen. Fire will be goes off. Fire will be goes off, that is hydrogen. With sound will come. If it is a hydrogen, this test tube we can keep like this. This flame will be goes off and one sound will come, like pop sound will come. Sound is POP, that is hydrogen gas. So then we can identify which is oxygen, which is hydrogen, like so that is different. So now here electrolysis of water, what is the ratio of hydrogen and oxygen gas? Mass ratio what? Hydrogen and oxygen. If hydrogen and oxygen, hydrogen mass ratio 4 grams, 2 2 are 4, oxygen mass 32. Now ratio of these two, 2 is to how much? 2 is to 16. So oxygen is 16, hydrogen is 2. Otherwise 1 is to hydrogen 1, oxygen is 8. So this is mass ratio. This is mass ratio. Now volume ratio or molar ratio. Molar ratio equal to molar ratio of hydrogen 2 moles, no? 2 is to oxygen 1 mole. So this is molar ratio, 2 is to 1 molar ratio for hydrogen oxygen. 2 moles to 1 mole, 1 front number only moles. So this is about electrolysis.